All right, good morning. Happy Thursday. I always say good morning. When am I going to stop saying that? I'm like totally trained to say good morning. Good afternoon. All right, hope you're all doing well. All right, yesterday I went over factoring methods, and there are 7. I didn't get to the 7th one, but I did teach the first 6 factoring methods. This is a prerequisite for Module 3, and there are a bunch of prerequisites. There's something else I put in classroom today involving radicals. So you must know how to simplify a radical, which a lot of times the Algebra 1 teachers don't get to, so I have to go over that. So, but before we get started, we are going to have an exam on Friday morning at 8 o'clock. And there have been some students that have notified me about various things, but I mean, it's going to be your responsibility to notify me about things that are scheduled. And you have to notify me before the exam, not the day before. It's too hard to change things if you let me know at the last minute, which would be the day before. So anyhow, just keep me posted things if you know something, because I can give the exam any day. But once I set it up, it's kind of hard to change. All right, so let's start with that first. So the exam tomorrow at 8 o'clock in the morning. Remember that you do have to take it, unless you've spoken to me about it for some reason that you can't. You are required to take it. So can't talk to me after the fact unless it was some type of emergency. So the exam tomorrow is on 2-1-2-2. Does anyone want to ask me any questions about 2-1 or 2-2?
For either lesson, are there going to be any word problems? Because I know you mentioned that for 2.2 there weren't going to be any, but I was wondering about 2.1.
Okay, for 2.1, there might be one word problem. I can't remember if I put it on there or not. Looking at the wrong chapter. Hold on, let me look at 2.1. Okay. In 2.1, you know how you had those, let's see. No, I didn't put one in there. So I did not put a problem in for 2.1.
Okay, thank you.
As far as 2.2 goes, I did not put one in there for that either. Yeah. All right, any other questions? How many problems are there? I think there's either 14 or 15 problems. So I did cut the number of problems down, but there are, I think, 2 problems that have multiple parts. Like, for example, in 2.1, there's a problem like number 18. And in 2.2, there's a problem like number 20.
Number 20 on what?
2.2.
Are you talking about the evaluate?
Yeah, I'm talking about the assignments. I always assign the book problems, right?
Oh, yes.
So I'm talking about the book in 2.2. And number 20, as far as I know, number 20 in the book is the same as number 20 in the evaluate online. So the problems, notice that the problems in the book match up with the problems on the online problems. They all match up. Okay, anything else with 2.1, 2.2? Okay, I did not make the factoring puzzles due like on Friday or anything. I made the factoring puzzles due on Monday night. So the first thing I want to do is I want to ask you, do you have any questions about the first 5 or the first 6 factoring methods? Questions about the first 6 factoring methods?
I don't think so.
Okay. So let me finish the lesson with the 7th factoring method, which is algebra 2, and that's the sum and difference of cubes. Now, there is a sum of cubes. There is no sum of squares. So don't try to factor the sum of squares because you can't. This is 2 terms also. So what happens here is if you have the sum of 2 cubes, it's going to result in the product of a binomial and a trinomial. And the signs are going to be plus, minus, plus. So if you have the sheet that I put in the material section for factoring methods, you're going to see the form at the bottom. So basically, is x cubed a cube? Yes, it is. Is 8 a cube? Yes, it is. So your answer would be x plus 2, and then what you do with the trinomial is you square the first one, square that one, and multiply the 2, and that would be your sum of cubes factored. The difference of cubes works the same way. If you have y cubed minus 27, you can set it up as the difference of 2 cubes. And in this case, you would have a binomial times a trinomial where this sign is positive plus plus. So this would be, is this a cube? Yes, it is. Remember, you always do a GCF. We couldn't do a GCF on any of these. 3 times 3 times 3 is 27. So you get y minus 3, square the first one, square the 3, multiply the 2, and that would be your answer. Now, it looks like you could factor these trinomials, but it's not until higher level math classes where you'll be able to factor those with higher powers. The problems we're doing right now, these trinomials hardly ever factor. They don't factor. So if you had a problem like that, you would want to do a GCF first. 2 times what is that? 2 times what is that? And you're not done. You notice that you have the sum of cubes. And remember, the sum of cubes translates to a binomial with a plus and a trinomial that's minus plus. Just like this one. So don't forget to let the 2 float down. It doesn't go away mystically. So this would be an x and a 2y times 2y times 2y. So this becomes 8 plus 2y x squared. Don't mess up on this. This is 2y quantity squared, which is 4y squared. A lot of times people will write 2y squared. The whole thing is squared.
Ms. Birch, can you move your camera to the right a bit, please? Thank you.
Yeah, so the whole thing is squared. 2y times 2y is 4y squared, and then this would be 2xy, the middle. All right, so that's the sum and difference of cubes. Does anyone have any questions about the sum and difference of cubes? All right. Would anybody like me to work any problems in the puzzles that I assigned? So nobody has a single question about the puzzles.
I'm formed just to see.
So does that mean you really don't have any questions, or you didn't start on the puzzles? Because that's what scares me is, let's see, yesterday was Wednesday, and lesson 2.2 was done at 11:59, but you should have been waiting to the last minute to do it. I mean, that should have been done. 2.2, I taught 2.2 on the 9th. Yesterday was the 16th. I know it didn't take you 8 days to do this assignment, so that can't happen. So I'm just letting you know, and I'm going to tell you, like I told my pre-cal class, you better be on top of things. And those of you who are not working an hour every day on your math, there's going to be some problems, because right now I'm going at a snail's pace and we're not even like where we need to be to complete this class. And so you should be doing work every day. If you're not doing work in here every day, there's an issue. So it shouldn't take you, for lesson 2.2, it shouldn't have taken you 8 days to do it. So all of you should have started on the puzzles last night. So I'm going to ask you again, does anybody have any questions about the puzzles? Because I'm going to teach something new today. Because remember, we're just reviewing supposedly. Now, yesterday when I kept asking about the factoring, a lot of people were saying, no, we never had this. No, we never had this. So I'm sure you put forth the extra effort yesterday, right? To make sure you knew the factoring methods, because you knew you were going to meet with me today and I was going to ask you about them. So I'm going to ask you again, anybody have any questions about the factoring?
Can you do number 10, please?
Number 10 on what page? There were 7 different pages. So what page are you talking about?
The first page.
The GCF?
Yeah.
So number 10 on the GCF. So it was 12x squared y plus what? 9x y squared. So we want to build a cake and we're going to do a GCF. So what is common in all 3 terms? So for sure a 3 is common. What else? How many x's are common?
So it'll be 3.
1. Well, we're doing one thing at a time. How many x's are common? 1. How many y's are common? Y. So now 3xy times what is that would be 4x. 3xy times what is that would be 3y. Then you look at your cake and say, oh, we got them all out. So the answer is 3xy times the quantity 4x plus 3y. And there's no room to show this work on this paper, so make sure you're using a separate paper. So there's no room to write on those puzzle sheets. You have to use a separate paper to do the work. Go ahead, I'm listening. And the reason why I'm antsy about this, because this is one of the most important things we're going to be doing right now. You have to know how to do this. If you don't know how to do this, you're not going to be able to do Module 3. So that's why I'm intense right now. Because there are no questions. You're not asking me about it. I hope you know how to do it. Because if you don't know how to do this, you're going to have a lot of trouble. So I'm just asking you, do you have any questions for me on this? There's going to be a lot of issues if you don't know how to factor.
Miss Birch, could you just go over real quick number 17 on the first page?
17 on the GCF. What is it? 8x to the 4th y squared plus 10xy cubed. All right, so you want to do a GCF, so we're going to build a cake, and we're going to look at what's common. So what is common in both terms? What can come out?
You can 2xy2.
Yeah, we can only take out 1x because he limits everybody. He only has 1x. And then this guy has y squared. He has a y squared. So we could take out a y squared, right? So this times what is that would be 4, x cubed. And this times what is that would be a 5. Why?
Yes.
So that would be your answer. You look at the cake, everything's out. xy squared times 4x cubed plus 5y.
Thank you.
Miss Birch, can you do number 12 on the 5th page?
Okay, number 12. And what sheet, what does it say on the top of that sheet? What factoring method is it?
It's, let me check. Factoring x squared plus bx plus.
Yeah. Okay, that's number 12.
No, that's page 5. Yeah, number 12.
Okay, we're doing number 12 on the page with the little monster with the fangs.
Yes.
So there's a little dot to dot with a monster with the fangs, and we're doing number 12. And that would be x squared plus 13x plus 36. Okay, when there's a 1 in front, this is a special case. And you could do one of two things. You can either guess what it is, what multiplies to give 36 and adds to give 13, or you can make a table like I showed you yesterday where you're going to multiply to get 36 times 1, and you're going to add to get 13. So if you guess, you're thinking, oh, 6 times 6. But 6 times 6 doesn't add to give 13. So what about 9 times 4? And they're both positive, so that's probably right. And if you FOIL it, it is. Now, if you don't feel comfortable doing that, you could go over here and say, okay, we have 1 times 36, 2 times 18, 3 times 12, 4 times 9, 5 doesn't work, 6 times 6, 7, 8, 9 times 4 starts repeating. So which of these add to give 13 would be 4 plus 9? So sure enough, there's your factors, x plus 4 and x plus 9. You want to get to the point, though, where you don't have to do this, where you can just guess and be able to FOIL to see if you got it right. So this is factoring method. It's 5. This also looks like a perfect square trinomial, so it could have been a perfect square. In this section, we're doing the form x squared plus bx plus c. Anything else?
Can you do number 8 on the last page, please?
Okay, what is the last page? Because my last page is different than yours.
It says grid word factoring.
Says what?
Grid.
Can you read the problem to me? Can you read the problem to me, please?
Yeah. It's 8a cubed, b cubed. I think that's a minus 6. I'm sorry, x to the 6th power.
Is that it?
Yeah.
Okay. So you can't do a GCF, and it's not the difference of squares. It can only be the difference of cubes. So we just did that. So we're going to look and see if it's a difference of cubes. If it is, it's going to be a binomial with a minus and a trinomial with a plus plus. So can you write this as a cube? 2 times 2 times 2, a times a times a, b times b times b, and this would be x squared to the 3rd, because that's x to the 6th, right? So your answer is going to be 2ab minus x squared. You're going to square this, which would be 4a squared b squared. You're going to square that, which would be x to the 4th. And when you multiply, it would be 2abx squared. So that one you probably wouldn't have been able to do because I just taught it. So the sum and difference of cubes, I just taught it. Anything else? Well, you know, you might be thinking, well, she gave us like a zillion problems. How are we supposed to do them? Remember, you're supposed to already know how to do this. So this should have been all of semester 2 of Algebra 1. You should be able to factor like that. That's what I need for module 3. So I need you to be able to factor. Remember, I wasn't even supposed to have taught this. This isn't even an Algebra 2 standard. So that's why I'm intense right now, because I need you to understand that you might have to be putting forth extra effort to get this down, because I'm ready to teach Algebra 2 and we're having trouble with Algebra 1. And I'm not talking to those of you who are working your tail off right now. If you're working your tail off right now, that's fine. I'm talking about those of you who are taking days off, not spending time on the assignments. I'm talking to you. That's who I'm talking to. People that are messing around. That's who I'm talking to. All right, so you have to know how to factor. Does anybody, before I go on, does anybody want to ask me about the factoring?
Sum of difference of cubes. It's from the notes. How do you get a number in the middle when multiplying the both numbers? That's where I get lost on.
All right, do you get the part where I'm setting up the form, the difference of cubes?
Yes.
Okay, do you get the fact that this means binomial times trinomial? This is the definition. When you have the difference of two cubes, it's defined as a binomial times a trinomial. Do you understand that? Okay. So this becomes x minus 2. You're going to square this one. You're going to square that one, and you're going to multiply the two together. And where does this come from? It comes from where it's defined. So this difference of cubes is defined as this.
I'm talking about like I understand the rest of it. It's just the 2x is where it throws me off.
You just multiply those, babe. Whatever those are, multiply them. That's it. 2x. Right?
Yeah, okay. Thank you.
2x. Whatever these two terms are, so let's say the two terms are xy minus 5. The middle term would be 5xy. You're multiplying them together.
I get it now, yeah. Thank you. I just wanted to know where it came from or how to find it.
Yeah, you just multiply whatever those two are, you just multiply them together. And if you're wondering, well, why did we do that? Well, that's the way it's defined. If you want to know why, you're going to have to look into some, heavy duty proofs about why you do that. Or you can just take my word for it that it's defined as what I'm showing you. It's defined as that. I personally don't think going into some proofs that are going to take up the entire period is worth going into. When you have a definition, we don't question every definition. It's a definition, we use it. All right, anything else about the factoring? Okay, well, today is a bunch of other problems because I need to have you be able to simplify radicals. So these are the conditions. You can't have any perfect squares under the radical. Can't have any fractions under the radical. Have any radicals in the denominator of a fraction. And the fourth one is Algebra 2, and we're not going to talk about it right now. The index must be as small as possible. Now, if I were you, I would put this in a box. I would make sure you have it right in front of you, because this is the only way you're going to know if a radical is simplified. So a radical is simplified when these conditions are met. And I'm going to start from square one.
Ms. Birch, what does number 4 say?
It says the index must be as small as possible. Now, I hope you guys had out radicals in Algebra 1, but if you didn't, we're going into nth terms. So a square root has a 2 as the index. It's invisible though, so you don't usually see the 2 there. In Algebra 2, we're going to go into the cube root, the 4th root, the 5th root. So I should be assuming you know how to do a square root, but I'm not going to assume anything. But we're going into nth roots. So I need you to know what a square root is. So this thing is called the index. What's underneath the radical is called the radicand. So did you guys have square roots in Algebra 2? Like, did you know that the square root of 4 is 2 times 2, and if you have a pair, 1 gets to come out?
Yes.
Okay, so if you have the square root of 9, you know that's a perfect square, 3 times 3, so a 3 gets to come out. Yes, you all had this?
Yeah.
Okay, did you get into what if it's not a perfect square? Like, what if it's...
Isn't it where like you take the number out and then you put it outside the square root or the radical? Or yeah, the square root sign?
Uh-huh.
Be like
Yeah.
2, 3. Yeah.
Like the square root of 28 is not a perfect square. So what you would do is kind of like this is where I'm going to tie the factoring in is in a prime factorization. You're going to take out a prime now. So instead of a greatest common factor, you're going to take out a prime. And 2 times what is 2? 2 times what is 8? Take out another prime. 7 times what is 14? This is a prime factorization. Did you guys do that stuff?
Yeah.
Okay,
Yeah.
good. Okay, so who comes out? Who gets to come out?
The 2 comes out and the 7 stays in.
That's right. Okay, good. Perfect. That's good. Yeah. So let's do another one. Square root of 154. Off to the side of the paper. Don't do it in line with your work. So you're going to do a prime factorization. I'm going to build cakes like we did. But instead of taking out a GCF, we're going to take out a prime number. So I'm going to take out a 2. So 2 times what is 15 without going over? It'd be 7 with 1 remainder. 2 times what is 14? 7. This time I'm going to take out an 11. 11 times what is 77? And it looks like that's simplified. So there's no pair of anything under there. We have a 2, a 7, and 11. Nobody comes out. What about the square root of 136 x squared y squared? Well, the prime factorization of 136, take out a prime, would be 2 times 6 is 12 with 1 remaining. 2 times what is 16? 8. Take out another 2. 2 times what is 6? 3. 2 times what is 8? 4. Take out another 2. 2 times what is 3? 1 with 1 remainder. 2 times what is 14? I think we're done. So this would be 2 times 2 times 2 times 17 times x times y. And I'll be honest with you, with square root, I just leave it like this because if the index matches the power, 1 comes out. So for example, when we get into the fourth roots, x to the fourth means an x is coming out. When we get into the fifth roots, x to the fifth means that an x is coming out. So whenever the index matches the power, 1 gets to come out. So who gets to come out here? A 2 gets to come out, an x and a y, correct? And
Yes.
who gets stuck?
34?
Yeah, 34, right. All right, well, I'm really happy that you guys know how to do this. That's cool. All right, so in classroom, I put a bunch of review sheets and I told you for this assignment that you only have to do the odds. Now, depending who you are, if you need more practice, you might want to do the evens also, but I'm just requiring that you do the odds. All right, now, let's talk about multiplying radicals. So this is all simplifying. If you multiply radicals, the rule says that you have to have the same index only. The radicands can be different. So you must have the same index. In this case, this is a square root and that's a square root, so we're good to go. Now, when you're adding and subtracting, you have to have the same index and the same radicand. We'll get to that in a minute. So on this one, you just multiply the numbers out in front and you multiply the numbers underneath. Pretty simple. But what if you have something like this? Well, I don't want to multiply 18 times 12 because I have a feeling that there's pairs hidden in there. So when I multiply 5 times 3, that's easy, but shouldn't I break down in a prime factorization of these guys? There's also a rule that says we can put these under 1 radical. So if we have the same index, we can put them under 1 radical. So the prime factorization of 12, you could just do it in your head, 2 times 6. So 2 times 6 18 is 2 times 9. So now, whoever gets to come out multiplies to 15. So who gets to come out? One, 2, 1, 3. And who gets stuck? A 6. So this ends up being 30 times 3 is what, 90? Radical. All right, any questions about what I'm doing with multiplying?
Miss Birch,
just have-
move your camera down a little. Thank you.
So just remember, the question that students ask is, how do we know when we're done? By that list I gave you. You cannot have any perfect squares under the radical. You can't not have any fractions under the radical. And you can't have any radicals in the denominator, which we haven't looked at yet. So this is multiplying. Any questions about this? So I guess the main thing I want you to see here is we don't gain anything. We go backwards if we multiply these out. We're trying to break them down. So don't multiply 12 times 18. Break it down to a prime factorization.
Ms. Birch, I have a question.
Yeah.
What happened to the second 3? Because there's 2 3s right there, and you said when you combine them you get 6, but what happened to the third 3?
Okay, first of all, see these 2s, 1 gets to come out. Those 2 3s, 1 gets to come out. And what's left is 3 times 2, which is 6.
Okay,
So,
okay, I understand
remember,
now, thank you.
Yeah, remember for every pair, 1 gets to come out. So here's a pair, 1 gets to come out. There's a pair, 1 gets to come out. And sorry, you guys, you have to stay under there. And that's 3 times 2 is 6. Can I erase this?
Yeah.
Okay. Let's take a look at division. I'm going to go real methodically through this. So. First of all, that is not simplified. Looks like it's simplified, but it's not. So the reason why this is not simplified is because it fails one of those conditions. So one of those conditions was you can't have any radicals in the denominator. So the way we get them out of there is we do something called rationalizing. So we're rationalizing the denominator. And the way we do that is we create 2 of them so that 1 comes out. So if this was 1 over radical 3, we'd be multiplying by radical 3 over radical 3. If it was 1 over radical 7, we'd be multiplying by radical 7 over radical 7. But remember that we have to multiply by 1 so that we're not changing the problem. So what happens here is this is really this. So 1 gets to come out. And on the top, you get 1 times radical 5, which is radical 5. and this meets the conditions. So there's no perfect squares under the radical, there's no radicals in the denominator, and there's no fractions under the radical. So this is considered to be simplified. Now, in this problem, I would not do this. I would simplify the radical first by getting the numbers out of there. So what I would do is I would do a prime factorization on 12, 3 times 4, 2 times 6, and 12 is 2 times 2 times 3. So who gets to come out? A 2? Did you guys follow that? I skipped a step. I can show it if you want me to, but if you followed it, I'm going to leave it like that. Give me some feedback, please. Did you follow that, or you want me to write it out?
Yeah, I followed it.
Yeah, it's easy to follow.
Okay. So the 2 isn't bothering anybody. So to rationalize, we would only multiply by radical 3 over radical 3, which is better than multiplying by radical 12 over radical 12. That's only causing more numbers and more work. So on the bottom, a 3 gets to come out, and 3 times 2 is 6. And on the top, you get 5 radical 3. And the only thing you have to be careful of is, can you cancel the 5 and the 6? Because that's part of a product. So if this was a 12 or a 2 or something, you'd have to simplify. But this does meet the conditions. There's no perfect squares under the radical. There's no radicals in the denominator. There's no fractions under the radical. Therefore, it is simplified. I know it doesn't look like it, but it is simplified because it meets the conditions. Are you guys okay?
Yep.
All right. So in this problem, this is even more different than the other problems. Okay, so let me talk about this. I'll talk about it right here. There's a product rule in Algebra 1, and it says that if you have a product under a radical, you can split it up. Or you can go backwards, like you've seen me do. You see me put it under one radical. There's also a quotient rule, division. And the quotient rule says that if you have a quotient, you can split it up if you want. So I noticed the relationship with 6 and 3. So since I noticed a relationship with 6 and 3, I'm going to put it under one radical and simplify. So that was pretty easy, and that was the best way to do that problem, is noticing that you can simplify. Now, if this was a 7, that would be a different story. In fact, I'll do one like that. But if there's a relationship with a 6 and a 4, an 8 and a 6, an 8 and a 4, put it under one radical and simplify. So what if it was a 7? Putting it under one radical is not going to help. And the reason why this isn't simplified is because you can't have a radical in the denominator of a fraction. So let's get rid of it. Multiply by itself. So radical 3 times radical 3 is the same as radical 3 times 3. So a 3 gets to come out. On the top, that's a prime, that's a prime. Nobody's coming out, b squared root of 21. And so that is simplified because there's no perfect squares under the radical, there's no radicals in the denominator, and there's no fractions under the radical. Okay, now, is this new stuff to you guys, or is this like a review?
The radical stuff, I remember doing it. It's not that hard. Or like it's not that hard to remember.
Yeah, it's like review.
Okay, good. Okay, so you guys are okay with this?
Yes.
Okay, I'm going to go over one more, and that's adding and subtracting radicals. All right. The adding and subtracting, you have to have the same index and the same radicand. So you must have the same index and the same radicand. So for example, if you had 5 radical 2 minus 7 radical 2, let me not use 2, let me use 3. The index is 2, right? Because they're both square roots. And the radicand is 3, so you can combine them like terms. So adding and subtracting with radicals, it's like terms. So if you have like radicals, you're just going to combine the numbers in front. So a positive and a negative depends, and opposites and subtracting don't change the radical. So just like 2x plus 5x is 7x, you just add the numbers in front or combine the numbers in front, but don't mess with the radical. So for example, if you had 2 radical 5 plus 3 radical 7, you have the same index, but you don't have the same radicand, therefore there's nothing you can do. You can't add them. Can't add them. So on all of these, you have the same index and the same radicand. You can combine all of them. So I'm going to put the pauses together. So this would be 4 plus 2 plus 1 is 7 minus 6 radical 7, which would be 1 radical 7. So look at this problem. Hold on a second. 4, 2, 5. Hold on a minute. So it's like, oh, we can't simplify that. We have the same index, but we have different radicands. But aren't there numbers hiding out in there? So wouldn't we have to do a prime factorization and get everybody out of there? So 20 would be 4 times 5, prime factorization in your head. And 125, isn't that 5 times 25? 25 times 5, is that right? Did you guys follow that?
Yes.
I just broke.
I got it. You got it.
Okay. So who gets to come out of the first one?
2.
So 2 times 5 is 10. And who gets to come out of this one?
5.
5 times 7 is 35. And look at that. Those are like radicals. So there were numbers hiding out in there. So these can be combined. So you have 4 to 45 radical 5. So you have to be careful if you can do a prime factorization and you can get numbers out of there, any pairs of numbers, you got to get them out of there. Okay, that's pretty much it for me in simplifying radicals. And this assignment is going to be due. It's due next Wednesday, but I mean, I'm just giving you extra time for no reason. I mean, you guys gotta be done with the factoring. You gotta be done with the radicals. You gotta be ready to go because I'm gonna start teaching a lesson and I'm gonna throw more things at you. You gotta stay on top of things. And all of this stuff that I'm doing right now is prerequisites for module 3. So I'm doing a review to make sure that you know what's going on before we get into this solving quadratics using factoring, solving quadratics using square root method, solving quadratics using graphing. So you got to know these skills in order to do what I want to teach. Okay, go ahead. I'm taking questions about anything, about factoring, about radicals.
Miss Birch, I have a question. So we're
Yeah.
not allowed to have a radical in the denominator, but we're allowed to have a radical in the numerator?
Yeah. Yep. That's right. So let's say you had 2 radical 3 over radical 7. That radical's okay, but you can't have this. So we would have to rationalize the denominator. So what we would do is we would multiply by a radical 7 over a radical 7 to get a 7 out. So you can think of this 2 different ways. You can think of this as radical 49, Or you could think of it as a radical with 2 7s under it, so a 7 gets to come out. So your answer would be 7 and 3 are prime, so it'd just be 2 radical 21. Now, the reason why this is simplified is because you don't have any perfect squares under the radical, you don't have any radicals in the denominator, and you don't have any fractions under the radical. Let me do a couple more. So if you had this, that is not simplified. And the reason why it's not simplified is because you have a fraction under a radical. So what would we do? We would say, okay, well, I can't have a fraction under a radical. I'm going to split it up. There, I got rid of it by using the quotient property. You can't have a radical in the denominator. So to get rid of it, we'd have to multiply by radical 5 over radical 5. So a 5 gets to come out, and radical 1 times radical 5 is just radical 5. And even though this looks better than that, this is considered simplified, that's not. Now, there's some more division ones that I want to go over with you that I just thought about. It's when you have something like this. See, you cannot get rid of that by just multiplying by radical 2, because this is stuck together. So the only way to get rid of this type of thing is to multiply by the conjugate. And the conjugate just differs in sign. So this is the conjugate. Now, what happens, conjugate? What happens when you multiply by the conjugate is when you FOIL, the outer and the inner go away. Always. I'll just show you real quick. Watch. 1 plus radical 2 times 1 minus radical 2, when you FOIL, would be 1 times 1. The outer would be negative radical 2 times 1. The inner would be radical 2. And the last would be radical 2 times 2, which is 2. So see how the middle terms, they're always going to cancel. And you're going to always get a nice number. So that's the beauty of the conjugate, is when you multiply by a conjugate, you don't have to do a full FOIL, because the outer and the inner are always going to cancel out. On the top, you would have to distribute. So that would be 3 times 1. Positive times a negative would be negative, what, 3 radical 2? Do you see this 3 in 3 terms? Remember I said you can't cancel parts of the sum or difference? Except when all 3 terms have a common number. So can't all 3 terms be divided by 3? So 3 times what is 3? 1. 3 times what is 3? 1. 3 times what is 3? Negative 1. So that's your answer simplified. And you must always simplify. I think I showed you something like this before. Like if you had 6 plus 12 square root of 3 divided by 8. Well, those are all divisible by 2, right? So when you have to say 2 times what is 8, 4, 2 times what is 6, 3, 2 times what is 12. Can you cancel those 2's?
No.
Absolutely not. You cannot cancel parts of a sum or a difference. Now, if we were going to write something in slope-intercept form, we could split it up, but that's not even linear. That's just an expression with a radical in it.
Okay, so Miss Birch,
What's that?
suppose we say like that 12 is a 13, but the 6 and the 8 are still the same. Would we still simplify the 6 and the 8 and just leave the 12 alone?
Okay, wait, I'm going to write it down. What did you just say? Say it again.
So on that problem, like 6 plus 12 radical of 3, supposedly say that 12 is a 13. Would we still simplify the 6 and the 8 because they're both like divisible by 2 or no?
No, can't. You have to be able to simplify all. There's 3 terms here. 1, 2, 3. You have to simplify in all 3 terms. If you cannot simplify in all 3 terms, this cannot be simplified.
Okay, thank you.
You're welcome. We're going over that because that right there is a big mistake that people make all the time. And so, yeah, you have to be able to simplify in all 3 terms. Let's do another one. What do you think about this one? Can you simplify that?
Yes, by 7.
No, you couldn't because you're gonna get rid of the other numbers, the 7 and the 14.
Yeah. So 7 times what is 28? 4. 7 times what is 7? 1. 7 times what is that? And that would be your answer. So see, these are divisible by 4, right? And you didn't see me put a 1 on the bottom because it's redundant. So we don't put things that we know that are there. So there's a 1 on the bottom. 4 times what? That's significant. You have to have it. 4 times what is 8? So that would be the answer. But the 1 on the bottom, we know it's there. All right, so let me advise you on what to do. What I would do today, excuse me, I would do the evaluate online to study for this exam. I would not do the factoring. I would not do the radicals. And you're going to study tonight and take the exam tomorrow for exam 2.1, 2.2. When you're done with your classes or whatever, you're going to work on those factoring puzzles. And then when you finish those factoring puzzles on Friday or Saturday or whatever, you're going to start right in on those radicals. Because I'm going to be teaching a new lesson on Monday. And you can't like blow things off and plan on doing the factoring on Monday to turn it on a Monday night and then do the radicals on that. It just doesn't work that way. Okay. So I hope I'm getting the point across, but you guys have got to stay on top of stuff, because when we get together, you have to take advantage of my time and ask me questions. Because if you wait to the last minute and it's 8 o'clock at night, I'm not around. So see, it's just a for disaster. Beyond things to be ready to ask me questions and get the most out of my time with you. Okay? All right. Anybody want to ask me any more? Anybody want me to work a problem, or anybody want to ask me any questions about anything?
No, I don't think so.
Well, you're going to want to memorize that. Well, you're going to want to know the factoring methods, number one. And you're going to want to memorize those conditions for simplifying radicals. So you can make up index cards, however you like to memorize things, like in anatomy or English or whatever you want to. I would make sure you know the factoring methods and you know the conditions for simplifying a radical. Okay? Okay, anybody want to ask me about anything? All right, well, we are done for today. I hope you have exam. I hope you do well. And I'm letting you out a little bit early, but it doesn't matter. Got a lot to do anyway, so. I hope you guys have a good day, and if you want to hang out with me, that's all right. All right, have a good day.
Have a good day, Ms. Birch.
Bye, guys. Have a good day.